About the acidity. So what is the acidity? How can we define the acidity? So if this is a reactant, and if it produce an anion plus a hydrogen ion, so if this anion which is formed is more stable, then we can say it is a good acid, and the production of hydrogen ion is easy. Hydrogen ion will be easily released, so it will be a good acid. So these are the two criteria in which we can say it is a good acid or acidity. And the acidity is directly proportional to the hydrogen ion concentration, as we have discussed here, and it is inversely proportional to the pH, and it is directly proportional to the Ka, and inversely proportional to the pKa value. So these are some important thing that we need to remember. Now let's talk about what are monobasic acid and what are dibasic acid. So as you can see, this is the example of monobasic acid, in which this hydrogen will be released and this type of anion will form here. So this is the example of dibasic acid. What is dibasic acid? Here one hydrogen is removed first, and it is Ka with a and a negative ion will form. So this is a monobasic acid, and another Ka is removed, or hydrogen is removed from here. So this two negative charge will form. So this is the example of dibasic acid. Now if you want to talk about the stability of dibasic acid, then we take an example such as COOH, CH2 with 0 here, and a COOH. These are called oxalic acid, and this is CH2, one is present, COOH. This is called malonic acid. These are called oxalic acid, and this is called a succinic acid. And there is a glutonic acid which has CH2 thrice, and CH2 thrice 4 times will have adipic acid with a COOH and a COOH, COOH, COOH. This is the structure of this. Now what we have to do is we need to talk about the stability. So as you can see, in oxalic acid, if we do dissociation constant, first acid dissociation constant, then the hydrogen will remove and a negative charge is present, and hydrogen bonding can be seen. So anion is becoming less stable because of hydrogen bonding weak. So if we go left to right, as you can see here, then hydrogen bonding that we are seeing here, the hydrogen bonding, the effect will be reduced due to presence of this group. This will increase the distance between this bond. So here less hydrogen bonding is present, so the stability which is caused due to this hydrogen bonding will be reduced in further. So the stability order for the dissociation constant will be Ka first will be more stable as compared to Ka second. So this is Ka first, this is Ka second, and this is Ka for third. So this will be the stability constant . Now if we talk about the second dissociation constant, acid dissociation constant for second order, so one negative charge is present and then hydrogen is removed. So this is called the case second. So what happened here is due to repulsion. So what will happen here is both negative charge is present. So here repulsion will be the main factor. So no hydrogen bonding. So as we go from left to right, the stability will increase because less repulsion will be available. So if this group come, this negative charges will go apart from each other, so stability will increase. So here if we go left to right in the acidic order, so stability order will be Ka first will be least and Ka second will be more stable, and so on. So here are some questions in which we need to see. So these are the all answer you can see here. Now let's talk about the ortho effect. It is the example of steric effect. It is a type of steric effect. The application of ortho effect is acidity of ortho substituted benzoic acid. So due to presence, what happened here, we can speak about the stability of the ortho substituted benzoic acid. So let's take an example here. So as you can see, a carbon with 2 oxygen and a hydrogen is present. So due to presence of this CH3 group, this repulsion factor will be present here, and it will be less stable as compared to this. And if we talk about the acidity, so more acidic due to ortho effect. This will be more acidic and this will be less acidic. So as we have seen in case of benzoic acid, the presence of this group or it is in resonance, and these bonds are present in equivalent resonance. So this is more stable and this is less stable. Why this is less stable? Due to presence of this negative charge. If hydrogen is removed, then another negative charge is present here, and if this bond is formed in this position, then and if positive charge will be here, so this will be less stable as compared to this due to equivalent resonance. So what is ortho effect is, when we put a increased group or a heavy group in the ortho position of this ring. So what happened here is, due to presence of this negative group, and we see for resonance to happen, as we have seen, for resonance to happen, there is the donation in empty orbital. So here what happened, due to repulsion factor, this bond, due to this heavy bond or big bond, the repulsion will be seen in this here, and this empty orbital or this orbital will go out of plane. So this will get out of plane, and donation will be stopped, so it will be less stable. So this effect can only be seen in benzoic acid. So what happened here is, when an ortho substitution in case of benzoic acid, orbital of C double bond O negative goes out of the plane due to repulsion factor. So resonance with ring stops, due to which carboxylate anion become more stable by equivalent resonance. So this is the what ortho effect means. So acidity increases of ortho substituted benzoic acid. So there are some examples, as you can see, acidic order, and in third question here we need to use this order. Now let's talk about the acidity order here. So it is hydrogen bonding present here and no ortho effect. So order will be like this. Now, so as we know that the number of substitution is increasing here, so as the number of ortho substitution is increasing, more the bulkiness also increases for the molecule, and COO bond out of the plane also increases. So equivalent resonance of subshell will also increase, and acidity will increase eventually. This is the order finally here.